Welcome to another installment of PESValuePropositions.com. I'm your host Mark Grant, and today we'll be looking at our energy management capabilities within PES. This particular value proposition is extremely powerful, and it will help you with your customer in regards to return on investment for his particular project. It will also certainly help him understand how this system can give him some instant information with regard to where his wastes are for energy and where his improvements with energy can come from. So, the first thing that we're going to do today is we're going to introduce you to the energy measurement capabilities of PES. Then we'll demonstrate the value of PES, the blocks, the energy blocks, and how they can show those energy costs and wastes. And number 3, we'll demonstrate how the energy measurements should also be used to determine if an application is out of control. And 4th, we'll show you a little bit of a behind-the-scenes look at the energy blocks themselves. First thing we'll do is we'll take a look at the actual process that we have in the demonstration. In this particular example, we have 2 variable speed drives attached to pumps. They are pumping liquid past the transmitter, past the valve, and into a tank. And what we have here is an example of a new motor, example of an old motor, and what we're going to do is we are going to simulate a couple of examples. We'll actually just simulate what happens when the pump gets old, and what we'll see here is that the RPMs will increase. But before we do that, we're going to ultimately define for you how much energy is used by the device, how much energy it takes to make the product, and how much energy it takes for the overall process itself, all the components. So let's take a look at the very first part. This particular control block is referred to as the electric control block. It has 2 key pieces. It has the part that is called total energy. Total energy is defined as the amount of energy consumed by the device, in this case the motor. And the second energy measurement is sampled energy, and that is the amount of energy that's consumed since the last start of a cycle. And we can go ahead and reset those, and you'll notice that that drops to nothing at the beginning of the cycle. The next measurement is process energy. And in process energy, we have, again, 2 different measurements that are available to us. First of all, we see energy intensity. Energy intensity is the instantaneous amount of energy it takes to produce a unit of product. In this case, cubic meters of the liquid. And then we have total energy. And the total energy is the amount of energy that it takes to produce the product over a given period of time. And that time period is user settable. So you could set it for 1 hour, you could set it for a full shift like 8 hours, you could even set it to a minute. And what it basically does is it kind of looks at the amount of energy in chunks of time. So if you've got an application where you want to see how much energy is being used to make the product every 5 minutes or every hour, then this is a good value, a good data point for you. Last but not least, we'll go ahead and we would take a look at the aggregated energy. And the aggregated energy, the most important part to take a look at, is the instantaneous amount of energy that's being used in the process itself. And then we also have the amount of energy, of course, that it takes for the producers and the consumers. So, let's go ahead and take a look at this application. First thing I want to do is take a look at how much energy is being used by each of these devices. This particular motor is running at 4,000 RPM using 4.4 kilowatts. This motor running at 5,000 RPM consuming 5 kilowatts, and the product itself is taking 0.18 kilowatts per unit to make. That's when everything is at a steady state. Now let's go ahead and do our demonstration, and we're going to simulate that the pump is getting older, which means the pump is going to have to work harder, and we can see what's happening here is the RPMs are increasing and of course the amount of electricity is more electricity is being consumed. And now we'll notice that the amount of energy it's taken to make that particular unit of product has gone up from 0.18 to 0.23. Roughly 0.25 is where it's going to stay steady. Okay? So immediately we're starting to see some things. While the process is still in control, we know that the tank is being filled appropriately, but what we're seeing now is it's taking a lot more energy to make the product than it had before. And we're also noticing that the overall amount of energy in the project, or the application, I should say, the process, has gone up to 11.1. The other thing I want to do is to explain again here that we measured that the process is actually in control, but because we start to see data points increasing, such as the amount of energy, just as we would take a look at a data point with the regulated amount of flow, we now can take energy as an additional data point, and we now notice that we've got a system that's out of control. And in fact, we're seeing it alarming right here based on that. Now let's go ahead and take a look at what's going on in these energy blocks. This is the engineering environment right here. We see a number of control blocks and inputs that are used to create and manage this pumping application. So first of all, we see the electrical block that we just mentioned. Okay, this is the electrical block, and what we see here are some basic things. One of the key things we noticed is that we mentioned before that we have a scan rate of 1 second. We saw that ramping up at 1 second. And this is where we could set our sample or our batch time that we talked about as 1 minute. We also now see the process energy, and then we see our aggregator block here. We see some of the other energy blocks that we have here. We have an air compressor block, block for boilers, carbon dioxide, gas, liquids, solids. These are all energy blocks that have been pre-created for PES. Now let's take a look at the information that we're seeing in real time, and we've used runtime navigation services in other presentations. But again, what we do is we hover our cursor over this particular block. You'll see it lights up green, and we click on it. We're opening up the runtime area for this particular block, and we'll start to see real values coming in a moment. So what we see here again, and this is the entire area of the pumping application. Here we see the electric block that we talked about before, and the inputs are voltages and power. In this case is the primary input. This is the second motor. These are our analog inputs, and if we scroll down, we start to see the other application. We see the aggregator, and you remember a moment ago we see that we have 11.1 kilowatts. There's our reading of 11.1 kilowatts, and these are all real values happening in real time. And then the process energy block, which is probably the most important block to take a look at, and we see that we have the real information coming in here: 33 kilowatts, 45, 50, and we see those values right there happening in real time. And you'll notice that we talked about before, there is a trigger for that particular batch that we talked about, whether it might be 1 minute, 1 hour, 8 hours, and that is recycling right there. Okay? And you'll notice that it goes down, it goes back up, and this is an alarm that we might be taking a look at. We might not want our energy to go past 100 kilowatts every 5 minutes, for instance, or something to that effect, and at the end of the cycle we see it drop back. So that's the key thing that we wanted to mention with regard to PES energy blocks. It's very important for us to be able to demonstrate the value of these energy blocks to customers so that we can show them where their energy costs are, where they're wasting energy. We want to be able to show them how They should be taking energy as an additional data point to prove that in fact an application is in control or out of control, and we'll know it's out of control with their energy imbalances. So I hope you've enjoyed this presentation on PESValuePropositions.com. I'm Mark Grant. I'm your host. Thank you very much.